x squared, y is equal to x squared plus x, y is equal to x squared plus 1, y is equal to x squared plus 5x plus 6. All of these are called quadratics. Quadratic equations in this case. Just this is called quadratic expression. This is a quadratic expression. So this is a quadratic expression. Right? So when that equate to something else, it's a quadratic equation. Yeah. So these are quadratic equations. So this is a one-term quadratic equation. You can see only one term here. So this is two-term. So in two-term quadratic equations, the second one can be a variable or a constant. This one, three-term quadratics. There is three-term quadratics. You see? So these are expressions here, right? And then equal to y, so it becomes an equation. Yeah. So now, if you have y is equal to x squared, right? Or y is equal to this. So now you understand, you can plot this. You can plot it. Why? Because if you want to plot, you have to have x and y. Right? If you want to plot, you have to have x and y. So indeed you have x and y. You can plot it. So can you solve it? No, you cannot solve it. This expression, this equation, you can't solve. Why? There are two variables. There are two variables, but one equation. So you can't solve it. Simple logic, right? Now, when I give you 0 is equal to x squared plus 5x plus 6, can you plot it? You cannot. Can you solve it? Yes, you can solve it. So these are very, very basics. Right? Now, if you think about this, remember, half is equal to sin x. This I explained to you. Sin x looks like this. If the domain is 0 to 2y, right? If the domain is 0 to 2y, and then half is y is equal to half. So I told you that you can extract this to be this. Y is equal to half and y is equal to sin x. Correct? Sin x and half. So similarly, you can do the same thing here. So if you have something like 0 is equal to x squared plus 5x plus 6, so you can consider this to be y and this to be y. Right? So this logic you can use anywhere. So this guy you can plot like this. So what you are plotting here, you are plotting y is equal to this. Y is equal to this, you can plot. Right? So you are plotting that. So then 0, 0 is this. So what is the answer when you solve this? These two coordinates. That's the answer. Right? It's very similar to here. This coordinate and this coordinate. Correct? That's how you do that. Okay. Now, so quadratic factorization. Quadratic factorization. Quadratic factorization you divide into two pieces. One is bracket method. Bracket method means if you have y is equal to x squared plus 5x plus 6, you do this one as x plus 2, x plus 3. This is bracket method. The second one is completing the square method. Completing the square method. So completing the square method I will teach you. So if you have x squared plus 5x plus 6, what you do is x plus 5 divided by 2 square plus 6 minus 20 divided by 4. So you do it that way. How do you get it? I will slowly explain to you. So I think bracket method, no need. You know bracket method, right? Yeah. Completing the square method, I will show it to you. Right? So I will erase this one out and show you how completing the square method works. Okay. So completing the square method. So first of all, you have to make sure the coefficient of x squared is 1. You have to make sure that, right? If not, you have to make it like that, right? So example, y is equal to x squared plus 5x plus 6, coefficient is 1, so good to go. Yeah. If you have something like this, 2x squared plus 3x plus 1, so you can see a problem here, 2. What you do is, you need to make it 1. How do you do that? You take 2 out from the entire thing, so it's going to be x squared plus 3 divided by 2x plus 1 divided by 2, like that, right? So how do you make sure you multiply with this and this and this, and then you make sure you get this back? This is the methodology. All good. Now how to do the complement in the square? So I'm going to show it to you. If you have y is equal to x squared plus 4x plus 1, so I'm going to show you how to do the complement in the square. This is pretty easy. Look at the board first, you can write it down later. So first of all, you look into this, then you write x plus 2. You take what is common here is x, and then you divide the coefficient of x by half, by 2, so which is this one. This one always you divide by this, so 2. Then you put that power here. Then you are going to copy this guy here, copy, there is copy. Then always minus, this is always minus square of this one, which is going to be 4. Done. So you can simplify this one to be x plus 2 squared minus 3, that's answer. So if I give you a complicated one, do this for me. So y is equal to x squared plus 2kx plus 1, where k is a constant. Where is k is a constant? Factorize it for me. So, how do you do that? We make sure this is 1 here. So you take this. So you have x and x, right? So x, what would be the coefficient? Coefficient is this. Divide by this, k square. Right? You are going to copy this plus 1. Then you are going to minus. What you are going to minus? This guy. K square. That's all. I have seen people do some unconscious work. Let me explain to you. Now, getting this answer is not the thing. Observing the pieces is very important. You have to understand, when you have inside this bracket, you can have only one x. Yeah. And then in here, no x's. Inside the bracket, you can have only one x. Here, no x's. Right? Some people do this by mistake. Some people do x plus kx square plus 1 minus k squared x squared. I have seen people giving me this answer. What they do? X, they know they have to divide this by 2, so they mistakenly divide, put the whole thing there. But they are so unconscious. Why? Because when they learn this for the first time, they didn't understand there can be only one x here. Yeah, so they are blindly including this, and they didn't understand that you cannot have x's here. So they are having x's here. So if you are conscious about this when you are learning, you can do mistakes in the exam. So you catch those mistakes and rectify in the exam. Yeah. So this is part of our training. Okay. Now that is part. Factorize y is equal to ax squared plus bx plus c. Do that for me. Okay, so now let's look at this. Firstly, you are going to take a out. So when you take it out, you get x squared plus b divided by a, x plus c divided by a. Agree? Then a. So you are going to take this and then divide the coefficient. So it's going to be b divided by 2. square. So then you peacefully copy this divided by a. Got it? Then always minus the square of this one. So it's going to be b square divided by 4a square. Agree? Yeah. So this is going. So a, this is going to be now x plus b divided by 2a square plus, now you get the common denominator here. So to get the common denominator, what you do, you multiply this by 4a and you multiply this by 4a. So if you do that, you get 4ac minus b square divided by 4a square. Yes. Right? So now here we are doing one more thing. We are going to take minus out from here. We are going to make this minus. Who can tell me why we are doing this? We are trying to make this minus. Who can tell me why we are doing that? Yes. Well, not always. So in this case it's plus 1. But we try to make it minus. If it should be minus always, there should be a reason behind it. I'm asking if there is a reason, what is that reason? We are going to make it minus somehow, right? So if you look at those parts, you can see minus 3 over there. So automatically it became minus. The other one, 1 minus k square. It is not actually minus because plus 1 minus k square, right? However, in this case, in general, we are going to make it minus. I'm asking why. Simple reason. You learn that in grade 6. I'm attacking your intellect, right? So that is the most important part to attack. Yes. Why we try to make this minus? I can leave it and go, but I'm not going to. I'm going to make it minus now. I forgot your name. You can say it. I forgot your name. Kevin? Kevin. Spell it for me.
K-E-V-A.
K-E-V-E-A. Kevin.
Yeah.
Kevin?
Yeah.
Kevin is easy for me, okay?
Yeah.
I'm from old school. Okay, Kevin. Why you make it minus?
Not sure.
Grade 6, 7. Reason. Reason. Now look at this. Take the simple version of this, okay? Take the simple version. Look at this one. Take the simple version of this. This has a lot of terms. Take a small version, right? So small version is y is equal to x plus 1 squared plus 1 minus k, something like this. Small version. Take a small version. When you have something like this, I am going to take minus out. So it's going to be k minus 1. Agree? K minus 1. Okay. Yeah. So this is why. Now, why I made that minus? Because of this reason. You know x-intercepts, right? X-intercepts. So if you want to find x-intercepts, mathematically, what would be the criteria? Y has to be 0. I will show you those things later. But mathematically, to find x-intercepts, y should be 0. Yeah. This you can simplify. How come? When you have a minus, you can bring it to here and that becomes positive. Then you have, so you have a positive term, right? You have a positive term. Then here you have x plus 1 square. Then you are going to get the square root, right? Yeah. So when you get the square root, you can write square root a positive number is equal to x plus 1. Agree? Agree? This square root is a valid square root. Why? Because it's a positive. You understand?
Yes.
Simple things. Yeah. But suppose here you are not going to make minus. You are bringing this one into here. So then this becomes minus. Yeah. This becomes minus. So then inside the square root you have a minus, which is invalid situations. So you are not going to give any chance to that kind of a behavior. So from the beginning, when you construct, you try to construct in that way. All good? There is another thing. My teacher didn't teach me this. I figured it out. Because if I learn it from my teacher, right, why not you learn from your school teacher? These things we figure out. Next thing. First thing is fine. Second thing. If you write in this way, if you bring minus out, this is 0, right? You can factorize it using difference of two squares. If you have a plus, you can't write this as a difference of two squares. That is the second reason. So if someone wants to do this, you can write x plus 1 minus k minus 1 square root. X plus 1 plus k minus 1 square root. So people can write this. And after, they can use NFN, null factor law, they can use equal to 0, equal to 0. Right? Whatever I explained with this small example is very important to your knowledge. Write it down in your words.
AC minus B squared.
Yeah.
Yeah, like the
So do you understand? Okay. So you understand we have this, right?
Yeah.
Zero. So I need to get the common denominator. So it's 4a squared. So I multiply this by 4a. So that becomes 4a squared.
But doesn't the 6 over A get inside the bracket?
6 over a. Right.
At the top, like 6
This is
over
C over.
I mean, sorry, C over A get inside the bracket.
What, this here?
Yeah.
No.
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 So you keep that out and then you make this common denominator at the bottom.
So you multiply this by 4a. So this becomes 4ac. This becomes b squared. So it's going to be 4a squared. If you're not sure whether this works, expand it, you should get this one.
Why do we get B divided by 2A?
Why? Because this is b divided by a. When you do the completing the square technique, so this coefficient should be divided by 2 only. Because you are doing the completing this square from here. You are treating here. So there the coefficient is b divided by a. So you can see here, look, you can see here, see? You are applying completing this square here actually. So when you do that, it's going to be 3 divided by 4. For this one. Here you don't have that, right? You have 1, right? When you have 1, this divided by 2. So when you have 1, this divided by 2. Similarly, when you have 1, this divided by 2. Yes.
If it's ax divided by a in the first part, what happens to the x with the x?
So this x,
Yeah.
right? That was ignored. That was ignored, and that is part of the construction.
Because you can't have two x's in the bracket.
I mean, none of the codes said you cannot have 2 x's in the bracket. But if you have 2 x's in the bracket, you are not going to get that form. I'll show you. Suppose you have y is equal to x squared plus 4x plus 1, right? So what I'm going to do, I'm going to write this, that. So this is going to be x plus 2 squared minus 3. So now you can see there is no x, right? Okay, I'm going to expand it. So it's going to be x squared plus 4 plus 4x minus 3, agree? So this is going to be now x squared plus 4x plus 1. You get that, right? Yeah? So that means if you ignore that x here, that construction works. Yeah? Otherwise, nobody said, oh, you must ignore that x. We ignore that x as a part of the construction. Now, you include it. Like this. You include it. Suppose this is the construction you believe. Yeah? Then expand it. So, you can see x plus 2x is 3x. It's going to be 9x squared. plus 1 minus 4x squared. Answer is 5x squared plus 1. Is that what you are having? No. Yeah? So that means this construction is wrong. Right construction is when you do that technique, you ignore that x and you leave it like this. That construction, when you absorb it like you cannot have 2x's inside the bracket. But there is a logical piece behind it. That is what I explained. Anything else? Yeah. Okay. So we are here, right? So we are here. So now I'm going to take minus out from here. So when I do that, a x plus b divided by 2a square. I'm going to take minus out, right? So it's going to be b squared minus 4ac divided by 4a squared. Done. Yeah. How do you make sure? Again, multiply. Minus b squared, correct. Minus minus positive, 4ac, correct. Yeah. So this is fine. Okay. Yeah. Now find x in this function. Find x for this one. Find x when y is equal to 0. So let me do that. 0 is equal to a x plus b divided by 2a squared minus b squared minus 4ac divided by 4a squared. Yeah. So what I'm going to do, now look at this. What I'm going to do, I'm going to consider this to be delta. Right? I'm going to consider that to be delta for simplicity. You can say A, B, C, D, B, Q, whatever, right? So now this A is not equal to 0. That means it's a non-zero constant. So you can cross multiply like this. 0 divided by A. You can cross multiply like that. When you do that, A is non-negative, non-zero, so it becomes 0. So x plus b divided by 2a square, yeah, minus delta divided by 4a square is what you are going to get. Correct. Now you understand the importance of this minus, because you can bring it to the other side. Yeah. So you do that. So it's going to be delta divided by 4a square. 4a square is equal to x plus b divided by 2a, the whole thing raised to the 4. Yeah. First listen and then you can write after. Otherwise, you don't do any of this. Then square rooting, right? So when you do the square rooting, plus and minus comes. Delta divided by, I would say, delta square root divided by 2a. Agree? When you square root this side, then right hand side becomes x plus b divided by 2a. So you bring this one to the other side. So when you do that, x is equal to minus b divided by 2a plus or minus delta square root divided by 2a. Now you can see automatically common denominator is set. So you can write 2a minus b plus or minus delta square root. What is this? What is this? That is x-intercept and that is called quadratic formula. That is quadratic formula. What is quadratic formula? Quadratic formula is minus b plus or minus b squared minus 4ac square root divided by 2a. What is this delta? So what is quadratic formula? Quadratic formula gives you x-intercepts. Right? Now you can see like how I'm deriving these things. I learned this when I was in your age. Okay? Do you think like I learned this when I was in the university? But still my blood talks. Reason? The way I absorb it when I learned it for the first time. So I want you to absorb it so that you will reproduce. When I ask from here, you should be like crispy clear. Oh, this is because of this, this is because of this, this is what, this will give you what, this and that, you have to explain to me. So until you get that maturity, you have to take a piece of paper and derive it. So one by line by line. This line, make sure, this line, make sure. Right? I have seen some kids, they just wanted to get the question, get the answer very quickly and done. That is not correct understanding. Right? So that's a half job. So we are wasting our time, right?